CentCom PACCell's new capability to connect any sensor in any domain to any shooter across the joint force. This new national security operational JADC2 communications capability provides resilient communications with minimal to no impact to warfighters in a contested and denied environment. It supports the joint all-domain operations for a joint fires network, ensuring JADC2 communications capability of sensors across services to weapons or shooters from the edge. This joint warfighting concept capability sustains joint and multinational communications across key regions throughout the world. It provides resilient communications across combined joint operations areas. And it provides worldwide CJAD-C2 communications. PACCell provides a complete CJAD-C2 C5ISR targeting system. We interface with the Army, Navy, Air Force, Marine Corps, and Space Forces and bring in their data into our system using our data fabric. We then bring in 35 different sensor feeds from UAVs, radars, satellites, ground and sea detection systems, etc., all while providing an up and down the chain of command exchange of communication along with geospecific marker and personnel location information for a complete common operational picture system. Here's a pictorial of how the system actually works. On the left-hand side, you see the data links coming in on link 16 from sensor systems such as AWACS, and then being transmitted out on a different channel to Air Force, Navy, and Marine Corps fighters with the command to engage. We bring in link 16 and OTH gold, and then that can go back out in the form of commands to the weapon systems that are capable of engaging. We bring in data from satellites, and that data can be translated and sent out in JVMF format to the Army and Marine Corps systems that are capable of engaging targets. We also bring in data from the Coast Guard and send data to the Coast Guard. We transmit that data out to 5-Eyes and link 16 formats. We transmit it out to NATO and NIFI and NVG formats. We bring in various satellite overpass times so we can track where all the satellites are. And we bring in 35 different types of sensors, including small and large UAVs and phased radar data. We showed that we bring in link 16 data and transmit out as JVMF, and then JVMF comes in and we transmit out as link 16 or OTH gold or anything that comes in on the right-hand side goes back out when the operator can select it to go back up. Uniquely, we bring in 35 different types of sensors, and that data can be selectively specified to be transmitted. As an example, we can bring in radar data like ADS-B and AIS information and automatically transmit that on link 16. We bring in ELINT data from satellite sources and transmit it out as link 16. Together, between the input and output associated with the data links and the input and output associated with the sensors, we provide the most integrated COP in existence. Please note at the bottom of many of these slides are links to videos that showcase this functionality. Here's an example of how our data link data fabric works. We're bringing in ELINT data from a Hawkeye 360 satellite. The data link translates the incoming message and sends it back out on link 16, automatically creating the corresponding tracks to the receiving system. This system runs on Windows PC as an installed application, Android and iOS handsets as an installed application. It runs on any device that has a browser as a web client, and now we run a streamlined version on the Galaxy Watch. We built a system that included 400 consoles for Ukraine that provided up and down the chain of command communications. This was accepted by the U.S. ambassador to Ukraine and used by their general staff. This shows how we use up and down the chain of command communications by using server-to-server communications, so that you would have a small server at each of the platoon and company levels. And then at the battalion level, you might have up and down the chain of command by satellite communications. We've had great success with Starlink satellite comms. Here's a screenshot showing the system while processing 10,000 aircraft reports throughout the world, even on the handset. Here's another example of the system bringing in ships and aircraft data in and around Southern California. Here we see 3,000 plus real-time unclassified sensor reports displaying real-time aircraft, ship, and ELINT sensor feeds focused in the South China Sea. The system supports a global COP and has the capacity to display 100,000 sensor reports. We can get detail on each of these sensor reports by hooking the symbol associated with it. We can hook an air track to get the aircraft's call sign, heading, speed and altitude, as well as range and bearing. When available, I can also get a representative image of the type of craft. I know this plane is an Airbus A321, and I get a picture of what an Airbus A321 looks like. Here we can hook a C-track to get the detailed info like vessel name, type, call sign, destination, MIMSI and IMO designations, as well as a range and bearing, length, width, and draft. Again, I can get a representative image of the type of craft. The bulk of the symbols you're seeing on the map is ELINT data received from an unclassified satellite source. Here we can hook a radio symbol. In addition to the location, we see the signal as VHF and we get the frequency and channel. I can hook another one and I can see that the signal is L-band. I can also hook a radar symbol. Again, I get the location as well as the signal, X-band. I also get the frequency as well as the repetition frequency and length of the pulse. I can also get ship symbols as ELINT data, so I know that a VHF signal emanated from this vessel. Through the LifeRing-enabled command center, we now have a scalable, integrated C5ISR worldwide common operational picture of the air, ground, and sea, integrating markers, ship traffic data, air traffic data, ELINT data, and more, and the ability to display 10,000 plus sensor reports and thousands of users simultaneously. If connected to US or NATO C5ISR systems, this data will automatically be transformed into the classified data links formats. Here we're bringing in 5 different radars in and around Savannah and processing the data. Simultaneously, our algorithm is throwing out data associated with waves, birds, mountaintops, and weather. Then we're providing correlation between various reports and throwing out redundant data and continuously sourcing the sensor with the highest level of confidence, so that in the end there's only one aircraft symbol associated with the combined radar data. Here we're bringing in swarm radar data, and we're simultaneously processing it and then transmitting it out to our displays, which can then go out to handheld units like ATAC or our own LifeRing clients. The LifeRing clients have additional capabilities beyond that of ATAC. This display shows us processing boats, cars, and a UAV, which is hooked in the center of the display. We process different sensors from the queue. The demo video shows us processing sensors located at various Air Force and Marine Corps bases throughout the U.S. as well as Korea and the Philippines. The data was transmitted up to an Iridium satellite and then back down to our server, where it's then displayed in real time on our PC client. Here we are bringing in ship data from a free-floating buoy that is self-powered based on wave motion. We're transmitting that out to an Iridium satellite and then back down to our server, where the ship symbol is displayed in our system. We can hook the symbol and view the AIS data associated with it. Now here we're tracking supplies moving across Florida. The vehicle has a tracking tag which is transmitting its location and movements. The vehicle has an attached manifest which can be viewed by hooking the symbol, creating an ad hoc logistics system. Here we are seeing synthetic aperture radar, or SAR data, overlaid on the map display. The advantage of having the SAR data is you get a clear defined imagery whether it's cloudy or nighttime. We are superimposing the SAR imagery in an area where we also have ELINT data of ships that are broadcasting on VHF radios. So we're seeing a combination of many sources of information on a single display here. Here's a screenshot of satellite imagery data for an area in Ukraine that's now occupied by the Russians. Maxar, Black Sky, and Planet Labs are just a few of the sources we use to bring in this data. Here we're processing 2 UAV flights, one located here in Jupiter, Florida, and one outside of Florida. We can simultaneously display multiple feeds from UAVs, security cameras, body cameras, or smartphone cameras and bring them into the display while also showing the location of where that video is coming from on the map. Here's an example of that, showing how we can process multiple sources of video coming into the system. On the left, we see the map display showing users' locations, and on the right, we see live body cam footage coming in from each user. We also bring in satellite data from a database that is provided to us by the U.S. Space Force. We can track most of the satellites in the world, and we superimpose a satellite path over a common operational picture, which you see here in 3D mode. This gives us overpass, paths, and times in relation to the ground and sea force symbols on the map. We take all that data and then we enable it to be transmitted out to the systems that can engage hostile forces. So we see here we're taking the data and sending it off to AFATADS and then to JVMF, and then it's being fired. This was actually tested out at the White Sands during the Bold Quest exercise. In the lower half, we see the ability to direct fighters to engage specific ground, air, or sea targets. We also enable the operators of the systems to see the overall picture of what's happening so they can discuss actual operations while they're occurring. We call it TEV, or Tactically Encrypted Video Conferencing. The advantage over Zoom and other such systems is that it can use the military's own computers and Type 1 secure communications and does not require internet. We have the capability to store data according to its classification level and then provide it out. So unclassified data would go out to everybody. Classified data would go out to just the US, Five Eyes, and perhaps Japan. And system high data would mostly go to the US and maybe some to Five Eyes. Here's a list of JAD-C2 requirements along with supporting videos that show how we meet each of them. For more information on any of the aspects of this video, please feel free to reach out to any of the points of contacts listed below.